Okay, Mrs. Marble, we're all set to go. All right, Mrs. Marble, we are all set to go. Okay, we're done here.
No, my toys.
Teleprompter's on, the lines are going.
My toys, they're irresistible to play with.
Your lines?
Magnets, they're
Your
so
lines?
fun. And I bet you've played with magnets too before. Magnets actually share similar properties to electric charges.
Whoa.
Just like charges, magnets exert a push or a pull, but it's the magnetic force.
The Force, like in Star Wars.
Just like that.
See? It's everywhere.
All magnets have a north and south pole. Like poles repel and opposite poles attract.
These properties that all magnets share can be explained by their magnetic field. A magnetic field is an invisible region where the magnetic force can be felt by another object. They're arranged in field lines coming out of the North Pole and into the South Pole. Opposite poles of a magnet attract each other because their field lines attract. With like poles, their field lines want to stay away from each other. You can even see these field lines if I sprinkle some iron dust onto this piece of paper. Notice how the field lines are jammed in at the poles. This is why magnets are strongest at their poles.
Okay, so we've covered the properties of magnets, but why does magnetism exist in the first place? Well, the answer actually has a lot to do with electrons.
All atoms have electrons, and all electrons display a property called spin. We can think of spin like an electron rotating on its axis like the Earth does. If the electron spins clockwise, an invisible magnetic field is generated from the top to the bottom. This is called a downspin. If it spins counterclockwise, the field is generated at the bottom and travels to the top. We call this the upspin. And moving electrons cause magnetism. But wait, then why isn't everything on this planet magnetic since all matter has electrons?
Well, electrons travel in pairs, like buddies, and one electron spins in one direction and has an upspin. The other electron is spinning in the opposite direction, so it has a downspin. And those two different spins cancel each other out, so the material is neutral, no charge. For you, no charge.
In materials like plastic, copper, and aluminum, electron spin is totally canceled out. But in materials like iron, nickel, and cobalt, the atoms have unpaired electrons, and they have the ability to spin in the same direction. If they do, you have an atom with a magnetic field. You multiply that by a few trillion in a chunk of iron, and you find yourself with a magnet.
But then, wait, why aren't all nails magnetic? They're all iron.
That's a great question. Well, electrons tend to spin in the same direction in small clusters of atoms in iron called domains. These domains act like mini bar magnets, which is why it's considered magnetic. But look at these domains. They're all pointing in different ways. This cancels out their tiny magnetic fields in the entire object. But the cool thing about domains is that we can align them.
If you were to place these domains in a strong magnetic field or rub them with a permanent magnet, it will line up their domains in one direction, making the entire object, such as an iron nail, become a temporary magnet. The more aligned they are, the stronger the magnet.
Like stormtroopers marching in sync.
Okay, if that helps you. Is that Star Wars?
Really? Really?
Okay, magnets.
May the Force be with you.